Thank you, Chair, for the introduction. This research work is a part of a Parkinson disease telemedicine project conducted together with Sapienza University of Rome, San Raffaele University of Rome, Gemelli Hospital, Casa di Cura alle Terrazze, and Technoscience. Parkinson disease is one of the most common neurodegenerative diseases that affects 2-3% of the population over the age of 5 years old, and is due to a degeneration of the nerve cells of the substantia nigra that produce dopamine, a neurotransmitter responsible for movement control and equilibrium. Incident factors of the disease beyond the age are the ethnicity and the gender. In fact, the disease is more frequent in Hispanic and white population, and in male subjects with an incidence rate of 1.5%, twice as high as that of the females, as shown in the graph in the figure. The diagnosis is rather delicate and requires an initial observation of the symptoms in the clinical history and of the response to the treatment with more specific examination, such as magnetic resonance, PET, SPECT, and CT scan. Symptoms are mainly motor, although non-motor features may present from onset, such as depression and sleep disorders, cognitive impairment, and so on, while the main motor symptoms are bradykinesia, tremor, muscle stiffness, balance disorder, and postural instability. Decreased manual dexterity and slowed movement often impair subject handwriting, which has now become an important objective biomarker of the disease. From the study of the literature, it emerged that the first deficit is micrography. It has an anomalous reduction in the size of the handwriting, which can be consistent. It has the subject decreases the size of his handwriting compared to a previous period, and this is evaluated by observing his signature during the years. The impairment of handwriting can also be progressive. It has the subject progressively decreases his handwriting as he writes. Often there is a decrease in the speed and fluidity of the handwriting. The letters tend to increase and to be more angular and squared or simpler in the shape. Another deficit is the inability to manage space and hence the inability to hold the line. Now, the data collection, it was very important. The system allowed us to build a new completely Italian database. The population under examination consists of 58 Italian-speaking subjects divided into 42 healthy and 16 Parkinsonians, mixed male and female, with an average age between 40 and 70 years, with the exception of a few declared almost all to be right-handed. The experimental setup provides for the subject to be seated in a comfortable position in front of a table on which the tablet connected to the operator PC is placed, which monitors the entire execution of the test. The protocol was developed together with the Italian-French Graphological Association and foresees the execution of 4 tasks. The first task is the drawing of an Archimedean spiral, widely used for the clinical study of the tremor. The second task is the writing on a blank page on the first line 6 times the digraph le. On the second line, the phrase I fiori sono sul tavolo. On the third line, nel cielo ci sono le stelle. The third task is the drawing of 10 concentric circles inside a guide. The fourth task is writing 7 lines of free text. This is a rather simple, fluid, and rapid test that takes about 3 minutes for healthy people and 4 minutes for Parkinson's patients. Therefore, a detailed analysis of graph and graphological signals collecting using a professional graphic tablet allow us to develop machine learning models that are able to discriminate an healthy subject from a Parkinsonian with an appropriate value of accuracy. The data analysis phase is important, with particular attention to the extraction of the relevant features for classification purposes. The professional graphic tablets use has an integrated Wacom One display with relative digital pen connected to the PC, which must have at least a Windows 10 operating system. The software used for data acquisition is the drawing app developed in a previous research work, which allows the collection of data relating the X and Y position, pressure, time, inclination along X and Y axis by the digital pen, while a Matrix software was used for the data analysis. In a first phase for data organization and preprocessing, in a second phase for the extraction and selection of features, and at the least phase for the training of machine learning models. At the same time, in order to propose a new mobile health solution, the two voice handwriting applications developed in the previous research work were taken and integrated into a single smartphone tablet application for both iOS and Android operating systems, called Voice and Drawing App application. This therefore allows the acquisition and storage in real time the data relating both graphological signals and voice signals. The graphic environment on which the application was developed is Meetup Inventor, which includes a designer section in which the various components are chosen, and a rag and a block editor in which the behavior of these components is dictated. The schematic figure shows the application framework, and specifically its protocol provided for the execution of the voice task, such as the recording of vocal sound and the execution of writing task, as the letters in the figure, on a white page, and the drawing of a spiral and a circle on a page with a figure that will have different dimensions depending on whether if you are using a smartphone or a tablet. Let's take a look at the methods used in the development of machine learning models. From the various tasks, features mainly described in the literature and belonging to the families of geometric and kinematic features, such as velocity, acceleration, jerk, and the dynamic features such as pressure and its derivative were first of all extractive. Of the absolute value of these quantized, statistical indices were also calculated, also described in the literature and reported in the table. For the task of the spiral, both of line geometric features have been extracted. It has extracted on drawing once completed, such as, for example, the distance between the points of an intersection of the spiral drawn with the Cartesian axis x and y, or the distance of the spiral drawn from the guide, calculating the parameter p, defined as the sum of the square of the distance of each point of the spiral drawn from its adjacent on one of the guide spiral. The lower its parameter, the greater is the precision. Other features are the geometric characteristics of the online type. For example, extracted as time varies, such as the volume of the cone, which has the largest circle of the spiral as its base, and the execution time as its height. Therefore, a greater volume means a greater execution time and a greater extension of the spiral drawn. For the kinematic feature, a low-pass filtering was also carried out, the trend of which is shown above on the right side. For the task 2, the 3 sentences were written on a single page, and the data was saved in a single file. Therefore, a first phase was necessary to separate the 3 lines with an algorithm that essentially observed the variation in the position of the digital pen, while in the second phase we proceed with the separation of the various components, therefore of the various li and the word sono. With regard to the separation of the li, both strokes on the tablet or simples for which the pressure is greater than 0, and stroke on the air or simple for which the pressure is equal to 0 were considered. With regard to the separation of the word in the sentences, before applying the algorithm, a preprocessing of the data was necessary. Therefore, asymptomatic segmentation was carried out, and the reason for this choice lies in the fact that many times the patient, when writing even one single word or inside the sentences, tended to lift the pen from the tablet several times, and it was difficult to find a common threshold that would allow this algorithm to separate all the sentences in a completely automatic way. Then, after having consulted the graphology literature and association, it was decided to focus attention on the single word sono, present in both sentences and occupying the central part of this, we think it may contain relevant information for the purposes of our analysis, as it could take over the patient fatigue. The semi-automatic segmentation was also carried out for the separation of the 10 circles, while for the free text, the data acquisition was carried out. But its analysis has its objective beyond that of the classification and of the screening. And the analysis of the emotional personological aspect could be a future work. Now, all the features extracted from the various tasks have been organized in two-dimensional matrices of dimension 58 for n+1. In particular, the last column is that of the labels, 0 for the healthy people and 1 for the Parkinsonians. The data considered relates not only to the individual task and subtask, but also to the 13 possible combination of these. A diagram of this is shown here in the figure. In order to obtain the best performance, a selection of the most relevant features was necessary for the classification using the Kolmogorov-Smirnov statistical test. At this point, we proceeded with the training of the models in classification learner. In particular, 20 models were built considering 100% of the data, and another 20 models by first performing a random division of the data into training set and test set with a proportion of 75 out of 25. The table shows a breakdown of the subject into the two training set and test set groups, and a tenfold cross-validation was used for all the models. With regard to the strategies used for the development of the mobile application, from the voice side, a user must first of all load his name, and the successful loading is notified by the notifier component. Before recording the voice, he waits 3 seconds, counted by the clock component. At this point, it records the voice, stop the voice recording, plays it, and save it. These operations are made possible by the components such as player sound for playing sounds and wave sound recorder for recording wave-type audio, with extension such as get SD and get API level. And both stored in the mobile application and in the Firebase database. On the drawings right side for both the blank page and the page with figure, the canvas component has been inserted. It is a two-dimensional block sensitive to the touch that allows to draw, while only for the page with figure, the image component has been inserted, which allow you to view the image of the spiral and the guide circle. Let's analyze the result obtained in the development of machine learning models whose performances have been evaluated in terms of accuracy, sensitivity, specificity, precision, and area under the ROC curve. The results we obtained were compared with those present in literature, however, obtained from the analysis of another database in the chess language, and with which we share only 2 tasks, the spiral and the digraph Lie. The results were compared in particular with those of Fratello et al. And Rotar et al. In relation to the 3 models present in the table, and in all 3 cases, we were able to obtain more performing accuracy values. The model with which we individually obtain a greater accuracy value equal to 88% is that of the task Lie, while a higher value equal to 93% was obtained in the combination of the 2. A value comparable only with that of Fratello, because Drotar did not analyze such combination. Here in the table, we report all the performances of all the models obtained considering the single task and subtask. The peak accuracy value reached is equal to 97% for the complete task 2, and the word sono. Another high value equal to 93% accuracy was obtained for the phrase I fiori sono sul tavolo. And the last column of the table showed the accuracy value obtained in the final test made on the test set. The best performing models were found to be the SVM, KNN, and the decision tree. Here in the table, we then report all the performances of all the models obtained considering the 13 possible combinations of the data. The peak value reached is equal to 97% obtained in the model highlighted in green in the table, and among these, in particular, is included the one that considers all of the tasks. With regard to the result obtained in the application part, the application was tested on both smartphone and tablets with both operating systems, and a pilot study was carried out in order to test the operation of the application and also the storage on the mobile, on the smartphone and on the database. As a goal, therefore, we were able to obtain a simple and intuitive application that takes a few minutes and can be performed directly at home in the total comfort of the patient. Possible future development of the work are a more detailed analysis of the guided sentences, since they turn out to be the most performing ones by focusing attention on single letter as well as single words. Another idea could be a change of execution order of the task, or a combined study of graphology and electromyography, inertial sensor upon the forearm, in order to study the link that exists between the handwriting disease, Parkinson disease, and the fatigue. In the future, we intend to use the developed application to increase the database and extend the analysis also to the voice in such a way to obtain a unique and complete machine learning model. Thank you for your attention.